This is the Google form of the problem I suggested for my class on probability and statistics. So here is the form, and the experiment was to take a dice and roll it 5 times and provide the output of every roll. And students were expected to provide their fair outcomes, and we have got 81 responses collected. So the outcome of first roll, outcome of second roll, outcome of third roll, fourth roll, fifth roll, and then the problem, how many times did you get only one dot face up? So these responses were collected, and now let's study the problem and compare it with the theoretical estimate. The problem is how many times the face with only one dot will show up in 5 rolls of a fair dice. So obviously there is no unique answer for this problem. In 5 rolls, 0, 1, 2, 3, 4, or all 5 times the face with one dot can show up. So we can compute percentage or probability of getting possible outcomes like 0, 1, 2, 3, 4, and 5 times one dot face appearing. So we have to compute the probability or percentage of all possible outcomes in many experiments. We got the responses, 81 responses, and I collected all those responses in the Google Sheet and then copied that one in the Microsoft Excel sheet. So here for X outcomes, that not a single time one dot appeared in 5 rolls. So we have the outcomes 2, 6, 4, 3, 2. Well, this is seems to be fair one. So in all these 5 times, not a single time the one dot face with one dot showed up. So we have all the outcomes. Let's first highlight the faces with outcome as one dot. So in all these 5 columns, I apply here conditional formatting would be fine. So I apply the highlight rule, and I'm only looking for equal to 1, equal to 1. Okay, good. So let's see whether the responses are correct or not. Okay, 1 is to 1. So 1 is to 1, 1. Okay, seems to be fine. And our possible outcome should be random 2, 6, 4, 3, 2, 6, 3, 6, 2, 1. Okay, 2, 6, 3, 6, 5. Okay, seems to be a fair set of experiments performed by my students in class. So now in all these 5 times trials rolls, how many times we got 1? How many times we got the face with 1? From probability point of view, since a dice has 6 faces, so every face has a fair chance of getting up as 1 by 6. So the number is about 16%. So if I calculate this number 1 by 6, so it is about 16%. So this is the probability of the face with one dot. Probability of one dot in one trial. So we performed 5 trials. Every student performed 5 trials, 5 rolls, and we are interested to get the count, how many times uh, he or she got uh, one dot. So for this very purpose, we have in total 81 experiments. So let's count the number of times we got uh, one dot face up. So let's count how many times we didn't get any uh, any time one dot face up. So here I apply the filter, and filter values where I didn't get any time the one dot. Okay, so all zeros and not a single one is highlighted. So therefore these are the experiments in which uh, the experimenters were were unlucky, uh, and they didn't get the desired outcome, which is one dot. So we have to count this one. So the count is 22, and I think it is 21. Yes, I am right. The count is 21. The by default counting includes this selected cell as well. So let's remove the filter. So we have got the count for zero outcomes as 21. Now let's count for the experiments in which we got once in 5 trials the one dot. So one. So it seems this is the correct outcome. It's a fairly big number. So how much is this number? Well, I have to select it and then see. Okay. So count is 49 and sum is 48. So it means there are 48 experiments in which we got this outcome. Okay. Then how many times we got the two roles giving up one dot in 5 trials? Okay, so the number of experiments in which this was possible, these are the 9 experiments. Okay, so I write here 9, and well, we didn't get more than 3 times the desired outcome. So 3, even though 4 times getting this desired outcome, it is also a possible case. Let's remove the filter. Okay, so 3 times we got this outcome, and then 0 and 0 for this one. And let's get the probability or chance. Probability which is based upon our experiment. So the total number of experiments. Okay, this should add up to 81. And now the crucial step, it seems these two values, one must be with the very large error. So let's see. So the counts and divided by the total number of experiments, I can get it from the position $11, not 11, 12. Okay. So 0.25, and that's it. So the numbers with the 2 successes, it is fairly close. This number is also fairly close. Well, we can compute the error. Let's compute the error. So experimental one minus the theoretical value. Well, this value is exact. So and divided by this one defines the absolute error. Okay, 0.1, and these are the errors. So we can compute the percentage error, that will give us the further information. So we can define the estimate from our experiment, the theoretical value divided by the theoretical value and times 100. Okay, 35%, and it was an underestimated value. Then the other one is positive. Okay, it is overestimated value, and so on and so forth. Well, while dealing with the small values, the percentage errors are quite misleading, uh, and they do not represent the right way to represent the errors. So therefore, it is good to stay with the absolute error, or the just the difference that we have calculated. So from probability experiments, if we do this experiment uh, some hundreds of times, several hundreds of times, so there are fair chances that we will get much closer result to the theoretical estimates.